Okay, so what that's saying is that the commutative property says, like, if you multiply A times B or B times A, you're going to get the same result. So the order doesn't matter there. Same as the addition subtraction. Okay? And then the associative property is you can multiply things in different orders, right? So that's what that says. A times B and then multiply by C is going to give you the same result as multiplying by, or multiplying B and C together and then multiplying by A at the very end. All going to give you the same answer. Okay, so again, I guess the theme here might be order doesn't matter. Okay? Now I had to practice this one. Okay? I had to do this one before I looked at this. I didn't really have a great idea as what the answer might be. So I had to come up with like kind of a, I had to go at it. Okay, so looking at problem 1 and using like commutative and associative properties, what do you think, or what would be your first step with this question? If I said no calculator on a test, what would be the first thing you would do? Do we have any ideas? So again, my job here, hopefully with this lesson, is to give you a couple little tricks, right? Because I don't necessarily want to go negative 25 times 125 times negative 4 times 6 times negative 8. That kind of hurts my head a little bit. By using those two properties that I just showed you, the commutative and associative properties, right? You could, what did we say? Order doesn't really matter, right? So could you flip those around to make it a little bit easier on yourself? So what if some of you are shaking your heads, yes, what order would you write this in again? Let's just flip the order around to something that maybe works a little bit better. Yes, Aaron?
So you could do 25 times 4, or like negative 25 times
Yeah.
negative 4.
Okay, why don't we start there? How many quarters are in a dollar? 4, right? What's a quarter worth? 25 cents. So if you got 25, 25, 25, 25, that's going to be 100. We like 100 because it's like one of these base 10 that we were talking about from the other lesson in period 3. Okay? So if we did that, we could go negative 4 times negative 5. What do two negatives make when you multiply?
Positive.
A positive. Okay? Two sticks make a plus, right? So let's go negative 25. Okay? And then we're going to go Are we happy? So what we could do is combine these two now, right? We know that that's 100. Okay? Okay, now, I think there's one more easier thing to do, and then we have some tricky stuff to do. So, what would you do next? Yes, Aaron?
I would do 125 times negative 8,
Okay.
which makes 1,000.
Okay, there you go. So if we take the negative 8 times 125, we're going to get 100 times, Aaron says negative 8 times 125 is going to be negative 1,000. And then we're going to multiply by 6. Okay, and I'll highlight in that red so you all know where it came from. You can follow, that's what I like doing sometimes. You can see if I highlight two things, I'll highlight it in the next line so you can see where it came from. And again, try to remember your equal signs as you go through here, okay? What would you like to do next? I don't really think it matters too much, but you can multiply the 6 by 100 or the 6 by 1,000, whatever you want, or the negative 1,000, right? So let's go 100 times negative 6,000. Okay? Does anybody know why we like these kind of base 10 numbers when we're multiplying? So we like these numbers. Yeah.
You just add the zeros.
Yeah, you just count up the number of zeros, right? So what I would say is, when you see something like this, ignore the zeros for a sec, because sometimes it's not going to be 1, it's not going to be 100, it could be 200, it could be whatever, right? And I'll show you a couple examples like that. Ignore the zeros. What's negative 6 times 1? It'd be negative 6, right? Negative 6. And then you go back and you say, okay, well, how many zeros are in there? Oof, let's see if I can get rid of it. How many zeros do you see?
3.
Is there 3? Total.
Oh, total?
Total.
6.
Sit. One more go. 5.
5? Wait,
1, 2,
is that,
3, 4, 5.
that's 2?
Yes.
Okay. Sorry.
There you go. That could be maybe my bad a little bit. Okay, so it's whatever the two numbers are. Well, I mean they're both. Sorry. This negative 6 times the 1. Do that. That's negative 6, and then count the zeros. 1, 2, 3, 4, 5. So that's 60,000. Everybody happy? Am I okay? Oh, sorry. 600,000, sorry. I put the comma in the wrong spot. Now are we happy? Alright, we're good. Okay? So now we're just going to take a look at a couple different variations of the same thing. Right? So using the picture below, we're going to try and explain why these two things are the same. And then we're going to use that property down in problem 3 to help us. Okay? So Mr. Poling was kind of nice when he made this question. It took me a sec to figure it out. Right? But he's kind of nice in the way that he's done this. So the reason why he's colored it yellow, you're going to see, which side do you want to start? The right side or the left side of the equal sign? I'm looking at this thing here. You want to start with the right side or left side in terms of explanation? So I was like, these are representative. The same thing, obviously, but when I say the right side of the equal sign, I'm talking about this. So this representation, do we want to start there or on the left? It's up to you guys. Yeah?
Right.
Okay, so let's take a look at this, right? So if we're counting this, what this is doing, obviously, is keeping count of how many boxes I have in this picture. Okay, that's what it's going to do. So I have a 3 by 2, 3, 1, 2, 3 by 2 wide. We see that? So that's this piece, the 3 by 2. And then if we're counting the number of boxes, we're going to add on a 1, 2, 3, 4 by a 1, 2, 3. Okay, that's the right hand side of that equal sign. That's a representation of the picture there, right? Maybe I'll do this. Okay, that's a 3 by 4. This box here. And I'm adding in the red box. Is everybody happy with that? And so obviously when I do the math on those two things, I should come out with the number of boxes that I see in that picture. Okay. Now the left side, if I reset here, is everybody okay with that? I think that was probably a good side to start with. A little easier of the two, I think. Just because of the way it's colored. But if I look at the left side, you're going to have 2, 1, 2, and then you're going to add in the other 4. 1, 2, 3, 4. And how many of those are you going to have? You have 3 of them, right? Okay, so that's where this came from. 3 times the 2 plus 4. Okay, in both those instances, they're going to give you the number of boxes in that picture, right? They're just modeled differently. Okay, and this gets to like the root of what we're trying to do today. It's like some of you might like the right side versus the left side, right? In your head. And it's completely personal, right? Okay, does that make sense of why we're doing this? Okay, so when we jump down here in a sec, again, like in looking at a problem like this, so we're gonna have like what we call the distributive property. Okay. And what that means is distribution. Have you guys ever seen distribution before? Distribution means like we're going to get rid of brackets. So from the left side to the right side, that's what's happened. We got rid of the brackets. That's what distribution does for us. Okay, and you'll notice what happened. When I distribute something into inside of the brackets, it went to both things. Right? And so when I look at the right side, I have AB now and AC. The A went on top of both of those things. Okay? So that's what we call distribution. Okay, and a little trick to help you with the first question or the first problem in problem 3, part A, would be, well, if you can go in one direction, you must be able to come backwards as well. Okay, I'm going to leave that for you for a sec. I want you to take a look at problem 3. Use that little concept, see if you can help yourself out with the calculation there. Okay, and again, you'll notice it says without a calculator. So we're just trying to emphasize being able to do this. Pencil to paper, or like in your head of some capacity, whatever. Now I'm also looking forward for like people to do different approaches so that we could talk about them. I have my approach that always works. If it's the fastest, I don't know, but I have my approach. Okay, and it's my kind of my go-to. But I'm interested to see what other people do. Okay, so in looking at 3A, I don't know if that's enough time. You guys feel rushed? You want more time to work that out? Okay, I'll give you another 30 seconds or so. Okay, I want you to concentrate on that blue arrow I drew on the underneath that distributive property, because I think that's the key to this question, in my view. Okay, that'd be you'll see how this doing things in a particular order it's like a little puzzle. It kind of unlocks one thing after another. Okay. So if I'm looking in that blue arrow in relation to the distributive property, can everybody see how I have the same thing twice? Okay, so distributive property tells me if I have the same thing in, we call these things terms. Okay, if I had the same thing across two terms, then I could bring it out front. Okay, so we can do something like this. You tell me if you disagree with this statement based on what's on the page. I'm using a lot of words that you maybe haven't heard before, but you will get used to hearing them. But at the very least, you should be able to make the connection with what I'm about to write on the page and the rule I just showed you. Okay, so I'm just going to write a little thing here. Does everybody agree with that? We all see it? I don't know if we can see it or not. So remember, if I get rid of all these little arches here. We had something on the right side of the equal sign for the blue arrow, and then the blue arrow brought us back to the left side. Okay? So we took whatever that A value is, could be anything, and this particular question is 51. And I wrote it out front of the brackets. Okay, now what's convenient about the inside of the brackets now? Could you do the math on that kind of easily? I think so, right? I think we could go 9 plus 31. What's that? 9 and 31 will make 40, right? Now here comes the interesting part. You might all have different approaches to do this. But what would you say now? What would be your next step? Do we know what? Yes?
You just did 51 times 40.
Straight up in your head?
No,
the table. Okay, I'm gonna show you the table in the next question, which is good. The way I kind of see that one's not too bad in terms of like I'm seeing. I know what the result of 50 times 40 would be, right? What would that be? I think so. Nope, bigger. 2,000. So you got to remember. Here, let's think. Okay, the table would probably be good here. You guys want to see the table? First introduction to the table. So if you think back to earlier, remember I showed you how to break down the numbers? That's the heart of the table. If you can do that, this process will work for you every single time, always. Okay, and it's kind of hard to make a mistake actually when you break it down. So how would I break 51 down? Do we know? Based on what I did earlier. 51 we could break down to something that looks like this. 50, that's its tens, and then you could break it into its ones, right? And then down the side, you just do 40. Well, 40 doesn't have any ones. It's 40. It's 0, right? So you can put it here. So then you create this table. And then to fill in the inside of the table, you just multiply. What did I tell you to do when you had zeros? Ignore the zeros. What's 4 times 5? 20. And how many zeros did you scratch off there? 2. Okay, so you're just going to add 2 zeros. Okay? Is that all right? This is kind of a fun method actually because it doesn't matter. There's no limitation to how big the numbers can get. It just takes more and more time. That's all. But this will always work. If you break numbers down like this. 40 times 1 would be 40. 0 and 0. Right? That's what we go here. So what happens when you add up everything on the inside of the square there, the little table? What's your result? You'd go 2,000 plus 40. So your answer would be 2,040. Does everybody agree? If you type that in on the calculator, it would be 2,040. Does that take longer than using the calculator? Absolutely. If you're in a pinch and you don't have a calculator, will that work? Absolutely. All the time. Okay, and it might come better into play or more into play in the next question. I don't know. It depends on what you guys do. You might teach me something. I don't know. Okay. Do we like dealing with negative numbers? If I ever see anything like negative and a negative, I try to get rid of it because it will lead to problems down the road when you have multiple negatives going on in a question. So if there's ever the opportunity to get rid of a negative, I would take it. Okay. So I would turn this into 9 times negative 56. Does everybody agree? So what could you do with this one? Well, why don't we break down 56 into its 2 components, if you will. 50 and 6. Does everybody agree? These 2 things add to 56. And we could put the 9 down here. Fill in the inside. What is 9 times 5? 45 with a 0 on it, right? So you have 450. What's 9 times 6? Add them together, you're done. What's that? Oh, sorry, I missed a 0. I missed a 4. 504. Is anybody impressed? Not yet? What happens if we multiply like 24 times 22, like from the last, like the Krispy Kreme? We could do that. You could do 255 times 362. There's no limit to how far this can go. It just takes more and more time to actually fill in the inside. We just break down the numbers. Everybody happy? Okay. All right, this is kind of the same. Problem 4 here is kind of the same thing. It's just showing the distribution of the 4 inside the brackets. Okay, so you could do, basically what it wants to do is like 4 times, what's 8 minus 3? 5 has to equal, what's 4 times 8?
32.
Yeah, it's 4 and 4. Okay, another little trick. 4 and 4 is 16, which must mean if I doubled 4 and 4, the 16 result, it would be 32, right? That would be 8 fours, right? So we know that's 32. And what's, we're going to take away, what's 4 times 3? Everybody should know that one. That's 12, eh? So, does this actually hold true? Well, 4 times 5 is 20. And 32 take away 12 is 20. So we're good. That looks like a 6. We're good. Okay? So there's your result there, right? It's virtually identical to, what is the same thing? Okay? This distributive property. It's just with a minus sign in it this time instead of an addition sign. Okay? Everybody freaking out yet? I hope not. What about this one? I suppose sometimes what I like doing it, when I learn these little tricks, I'd never seen this trick before like a couple years ago with this table. Never seen it. And if you put that in front of my grade 9 self, I would have freaked out. And told me to do it without a calculator? How am I supposed to do that? You might be thinking that right now. But I just gave you a method, so let's try and follow it. Let's take 998, okay, and let's break it down into its digits, or its base pieces, I suppose, right? 990 and 8. Down the side, 200, 0, no tens, and 1. Do we agree? So let's draw a little table. Let's fill it in. Remember, the zeros are kind of your friends. You could scratch them out and just multiply. So what's 2 times 9 with 4 zeros on it? 2 times 9 will be 18. Then add your 4 zeros. Oof, I didn't make that big enough. Still almost didn't fit. All right. 2 times 9 again, but this time you don't have 4 zeros, you only got 3. And then 2 times 8 with 2 zeros. It'd be 16 with 2 zeros. Is everybody following along? Are we okay? So remember to fill the inside of this table out. You think back to your like elementary school days. How would you find the area of like a backyard or the area of the room? Do you guys remember what the area of a rectangle is? Yeah? It's just length times width. There's a reason. So the reason why I'm showing you this, it'll come back into play in later parts of the course, right? Area, which is the red box, that's what we're filling out, is length times width. That's what we're doing. Okay? And then to finish it off, you just got to add up all the pieces. Well, 0 times 900, that's 0. 0 times 90, that's 0. You get a row of zeros here. That's kind of nice. And then we get to fill out the other part. What's 900, 90, and 8? Because it's 1 times each one of these pieces. Okay? Your final step, let's say I gave you this and you had no calculator. You just add up everything on the inside. Okay? So it goes something like this. 180,000 plus 18,000 plus 1,600 plus 900 plus 90 plus 8. Add it all up. 8, 9. 9 and 6, so make 15, carry the 1. 8 and 2, make 20, carry the 2. And there's a 2 and 8 makes 10, 11, carry the 1, there you go. 210,598. You could probably do that faster without me talking at you. You just, away you go and get it. This to me, when I saw this, I was like, this is brilliant. Absolutely brilliant. Did I do everything right? Is everybody checking? Making sure I'm good? Did I do it wrong? Did I make a mistake? No? Did I? Okay, where is it?
You carried a 2 when you added 8 plus 1 plus 1.
Oh, my bad. Should be a 1. I knew that number didn't look too familiar because I did do this question. Should have carried a 1 there. Is that what you're saying?
Yeah.
Okay. And that turns into also a 1. So that looks better?
No.
Last one. No, I know what I did. That looks better. Alright. We good? We good now? Some of you had like mad looks on your face. Just relax. You just did one thing wrong. Alright. Alright, I like that method. You can see it is kind of, you can make a mistake easily, but it also works 90% of the time without making mistakes. It'll work 100% of the time, you just can't make any mistakes. Okay? So, for the reciprocal is a fancy way of saying basically a fraction. Okay? Division. You could kind of like fraction or division. Or flip it. Another word is like flip. I've seen that used too. Okay? So I think when you see the word reciprocal, you should think like fraction, like something on the denominator. Okay? Reciprocal. Okay? So that means flip, division, whatever. Okay? Fraction. So for instance, if we look at this, has anybody ever multiplied fractions together? Out of curiosity? What can you always divide yes? Yeah. What can you always divide something by without changing anything?
1.
Yeah, you can divide anything you want by 1. Right? And so let me just rewrite this just to prove to you this statement's true. 1 over a times a over 1. So what happens when you multiply fractions together? What do you do? What's the rule? Like, what's the process? You multiply fractions together. You always take the top times the top and the bottom times the bottom. So you're going to get a over a would be the next line. What is a divided by a? Does it matter? Forget that it's a. Does it matter if what's 4 divided by 4? Yeah, it's just 1. If you take something, whatever that something, it doesn't matter. In this question, it's a, and you divide it by the same something, that's 1. Doesn't matter if it's 4 or 4 divided by 4, a divided by 8, whatever you want. It's 1. So that's the proof, okay? That's why this works out. Okay, so what's the product of 1/4 times 4 as a result? Yes?
1.
It's just 1, right? Because if I go 1 over 4 times 4 over 1, I'm going to get 4 over 4, which is equal to 1. It's top times top, bottom times bottom. This one's a little trickier. Okay, these two things, well, whenever you see an equal sign like this, it's easy to gloss over equal signs and not take them at their face value. But these This is saying that these two things are the same thing. Okay? So it's saying, you'll notice the difference between the two. You've got a division here, and then all of a sudden, somehow it became multiplication. Oh, yeah?
I forgot to mention this earlier, but
Yeah.
I'm going to need to go.
Oh, it's okay. That's okay, buddy. Okay? Whenever you need to go, you go. Okay? And then I'll finish recording it all. You can just watch it later, okay? If you need to. Okay? So, that's the interesting thing with this question. Somehow the division turned into a multiplication. Do we have any questions about that? Are you multiplying by the same thing? This is just kind of one of these rules that like somehow just found its way into my head. I never really got, I'm sure I got shown it. It just took forever for it to like get in there. Right? Dividing by something is the same thing as multiplying by the reciprocal. Does that mean anything to you based on what we've discussed so far? Okay, so if I looked at this, what's another way to write this? A divided by B. I think we could all do that one. What's A divided by B look like? Do we agree that it looks like this? I think so. I think that's pretty conventional, right? What did I just show you about the other side, though? If I multiply fractions together, what does it turn out to be? It's A over B. Did I do good? All right. Do you need to ever show that to me? No. Do you need to know it? Yeah. Just one of those things that like it'll lock itself in there. You just know it. And it'll come into play when you start getting into, when we start solving questions with fractions. I don't necessarily think, we might not do it in here, but we might. You might come across it in here. Maybe. Okay, I'll make a special note to bring this back to your attention if we come across it. Okay, you will see it at some point in high school. Okay, but anyway, that's an important one. Dividing by something is the same thing as multiplying by its reciprocal. That's what that means, that particular example. Okay, and so when you see something like this, we have negative 16. You could divide, what you might see sometimes is like this. Okay. Sorry, I'll move that up. Okay, I did that verbatim. But this looks pretty ugly. Like you have fractions inside of fractions, and that's kind of like, I don't like that either. Okay, so the way to untie that, or just to avoid that from the very beginning, is to say this. Negative 16. What's the, first maybe, what's the reciprocal of this? Or opposite, flip. Remember, this those words. Fraction might not be a good one, but flip is. Flip you could associate with reciprocal. So what's the reciprocal of 1/5? 5 over 1, because I flipped the fraction. That's the reciprocal. I'll write that down. Okay, so when we say multiply by the reciprocal, you'd multiply by 5. I don't need that one. Let's do it this way. What's 16 times 5? Yeah, I think so too. Okay. Is it 80? I know 80 is good. Is it just 80? What's the question have in it?
Negative.
That's got to be negative 80. You got to be careful, okay? Okay. All right. This was about as far as I got before I started going on. Well, I didn't go off the rails. I just never finished. Could we write this? This is you could do this in a nice way and maybe a not nice way. Like you might choose to multiply all these numbers out by like get a number in the bottom and the top. That could work. I don't know if that would work or not. What I would do is maybe write this out the way it is right now and see what happens. So what's the division mean? Literally, just write it underneath. Okay, so we're going to get 20 times 24 times 28 times 32. And then the division tells me to write the rest all underneath. Do we agree? I did exactly as it said. Right? Now, what's nice here? And there's kind of a key thing you have to remember. There are no plus or minus signs in this question. So that makes your life easy. If there are plus and minuses, you need to be cautious. Okay, but there are no plus and minuses here. So what are you free to do? This question just naturally, it just got worked out. Like it was written nicely for you. You must be careful if there's plus minuses, but there are no plus minuses here. So you can just look vertically up and down. What's 20 divided by 10? 2. 24 divided by 12? 2. 28 divided by 14? 2. 2. What is 2 times 2 times 2 times 2? 2 and 2 is 4 times another 4. What time we got? Almost there? Oh, it's almost close. Okay. How about when you come back, I think there's some questions you guys could probably tackle for homework. Probably all the way up to here. How about all of number 1? Okay. When you come back tomorrow, I'll finish off the rest of this and we'll start another lesson and then I'll give you guys some time to work, okay? But I think you could probably handle all the questions in number 1 tonight. Okay? So stack a chair and then you're free to go.